Hi, my name is Victor Olson. I'm here to present the paper ClassMix Segmentation-Based Data Augmentation for Semi-Supervised Learning. The state of the art in semantic segmentation is steadily increasing in performance, resulting in more precise and reliable segmentations in many different applications. However, progress is limited by the cost of generating labels for training, which sometimes requires hours of manual labor for a single image. Because of this, it's useful to be able to effectively harness semi-supervised learning. A key challenge is that common augmentations used in semi-supervised classification are less effective for semantic segmentation. We propose a novel data augmentation mechanism called ClassMix, which generates augmentations by mixing unlabeled samples by leveraging on the network's predictions. This augmentation strategy is used together with consistency regularization and pseudo-labeling to obtain state-of-the-art results for semi-supervised semantic segmentation. The ClassMix augmentation can be explained using this diagram. We start with two unlabeled images, A and B, and a segmentation network F theta. The images are propagated through the network, resulting in an argmaxed predicted semantic map for each of the two images, such that each pixel is assigned a class. These maps are denoted SA and SB. We then use one of the semantic maps, in this visualization SA, and randomly select half of the classes present in the predicted map. This is used to create a mask, M, which is 1 for the pixels belonging to the randomly selected classes and 0 for other pixels. This mask is then used to mix both the two images A and B and the corresponding semantic maps SA and SB, such that pixels where the mask M is 1 are from A and pixels where the mask is 0 are from B. This results in a mixed image XA and semantic map YA. These two are then used in training by feeding XA through the network and calculating the cross-entropy loss of the output against the pseudo-label YA, thereby enforcing consistency between the original images and the augmented one. This constitutes the unsupervised part of our semi-supervised learning approach. Here are two examples of ClassMix being used to create augmented images. Using ClassMix produces strongly augmented samples while keeping images more realistic looking than many other augmentation methods, which we believe is beneficial for training. And although the mixed images and pseudo-labels will contain some noise, consistency regularization tends to yield good results despite this, a fact that is also proven by our results. This table shows our mean intersection over union results for semi-supervised learning for the Cityscapes dataset, where we train our network on a limited number of labeled images while also training with a number of unlabeled images, where ClassMix is applied only to the latter. We show results for 4 different amounts of labeled data and compare our results to 4 existing works in the same field. As you can see by the bold fonts, our method performs better than the comparisons for 3 out of 4 data amounts, and the improvement from the purely supervised baseline is better for all 4 amounts of data. In the paper, we also present results for the Pascal VOC 2012 dataset. To evaluate the effect of the augmentation ClassMix, we here compare our results to networks trained using the same setup, but instead of ClassMix, using the common mixing technique CutMix. The top 2 images to the left are original samples from the Cityscapes dataset, and the bottom 2 are examples of augmented samples using ClassMix and CutMix respectively. The image mixed using ClassMix is more realistic looking, and we see in the table that ClassMix performs significantly better than CutMix. This indicates that the augmentation ClassMix is indeed useful. We present a more extensive ablation study in the paper. To conclude, we have presented a novel augmentation method called ClassMix, which mixes images based on predicted segmentations. This results in highly diverse augmented samples, which we use together with consistency regularization and pseudo-labeling to obtain state-of-the-art results for semi-supervised semantic segmentation. Thank you very much for listening.